Hello, I'm going to talk about the design of continuous delivery system, such as like Argo CD, which has a goal to get some manifests for resources defined in code, and then update some resource cluster, like for example Kubernetes cluster, with the manifests which are configured. So let's go through the topics. So first I would be clarifying questions and requirements, then high-level components. So we'll talk about repositories and their server, and applications and their controller. We'll talk about gradual rollouts with canaries and some webhooks for a faster applications refresh. Can be a lot of concepts, so let's go through questions. So first of all, where a resource manifest can be stored? Is it like GitHub, some hosted Git repository or non-Git repository? Most likely in modern time it's gonna be Git, but there can be different considerations like security, for example, versus convenience, and like you need to talk to the interviewer to see like if you have any like specific requirements. And then what's the system where resources reside? Is it like Kubernetes or similar system, some proprietary system, etc.? I think Kubernetes would be like a good topic to start for a discussion. It's pretty like standard these days for like compute resources, but depends on like the role you're interviewing. If you're interviewing for some like say competitor of Kubernetes, they may wanna like ask you for that specific like system. Then and then questions which is like probably gonna be out of scope. Do we have design deployment flow, for example, to get a new manifest to the repository? And then do we have to run any kinds of tests before rolling out changes? So do we need like CI, or do we need some canary for new image versions? And then like additional questions, like for example, what's the acceptable delay between new manifests available and our system checking for updates and taking actions? Is it like a few minutes delay okay, or are we required to do it like as real time as possible? And you can ask a lot more questions, like for example, what's the expected complexity? Because like for instance, one way to design it is just to have some GitHub action, which like when you update some your repository with manifests, it's gonna like call for maybe some kubectl apply on your cluster. That would need to be like carefully configured for security reasons, because you're essentially exposing your like control plane to the internet, and you need to make sure you have proper authentication authorization, or maybe just like not do it at all. But as opposed to like you can have a system which resides in your cluster as well. So then let's go to high-level components. So overall, like on the left side, there is like the typical combination with like resource cluster and manifest storage, and continuous delivery system sits in between them and kind of reconciling them. And let's go over on the right side, potential set of components. So we have a resource cluster, manifest storage, and then we have like some Redis, service, and cache. It's for caching various manifests, or caching like any like supplementary data we may need. Maybe it's caching like some cluster information, for example. And like big system would have like various number of caches with various timeouts. It's probably going to be configurable. So an application controller, will go over it in a bit more detail. It basically takes care of like a reconciliation between what the manifests are and what they should be. A repository server, it takes care of like working with like repositories such as like Git repository and fetching the data, caching it. Then there is web server to access basically like a UI for like your system and check what the status of like various applications and like maybe repositories and like your current user information, etc. And then there is a rollouts controller. This is like a part which is for gradual rollouts. For example, if you have some new image, you don't want to like possibly roll out it for all pods at once, because if they're bad, then your service can go down. And instead you may want to do some gradual rollout, maybe like rollout for a small percentage of pods, run some tests, check like error rate, etc. And for this one you would need like a separate controller pretty much. Let's talk about repositories in the server. We can support multiple kinds of repositories like Git or Mercurial, or like all kinds of Git like GitHub maybe, etc. As long as they adhere to some common interface. Maybe some have some file fetching functionality, authentication, authorization, and typically you can configure them using some secrets in your cluster. So for the reasons because like those secrets may contain credentials and you don't want to expose them in the config in a raw format. Then repository server takes care of authentication with repositories, fetching manifests, caching them. Fetching can be done on request or of one of components or like on some periodic basis. Most likely in this case like application server would be fetching this. We can have set up with a Redis cache or without a Redis cache, and if we have a Redis cache, manifests can be put there for like more higher availability and more like a little bit more durability for our cached data. Also since it's cache, it's not gonna be super durable anyways. Then let's talk about applications. Application is a collection of resources that are updated together. So for example, it can be some of microservice can correspond to one application. And you may have several deployments, some config maps, and some services if you're talking about Kubernetes. So it's primarily defined by a repository path for getting manifest. So you can say, hey, for example, some root of the repository slash some like production slash my service slash, and it's gonna read this repository or directory contents and like know that, hey, these are related to a group of applications related to my service. There is a notion of live manifests, what's in the cluster, and target manifests, what should be in a cluster. The application control is a component that reconciles these differences by a process called sync. Sync can happen also in waves to take care of dependencies between resources. For example, if you have some config map that deployment can depend on, you definitely want to like update config map or like create it before syncing the service. The controller refreshes the state of a repository and computes the diff between live and target manifests, and it can initiate a sync if there is a diff, and sync is configured to be done automatically. And the controller can maintain a cache of the cluster state for better performance and to like avoid being rate limited by the control plane, for example. Then gradual rollout with canaries, as I mentioned, it's pretty important to have some like safeguard to roll out gradually and be able to roll back if something doesn't work well, because you cannot have like people interfering like all the time. You need some automation. Caveat is like your metrics need to be pretty stable, which you use. Like for example, error rate is usually a pretty good one. But if your like target metric is flaky, then like it's gonna cause a lot of false positives and to frustration of engineers and like production engineers. Canaries can be configured like can give example based on like Argo CD in Kubernetes. It's called analysis runs resources, which are based on analysis templates. A template can be example, for example, instruct the controller to check the error rate for a new version of a service and require it being below some threshold. And then analysis run is pretty much like instantiation of that, which is like managed by a controller. So it actually does a run, it does like some periodic checks after like setting up the canary and rolling out some new pods. And then management of this canaries and gradual route is done typically by a separate controller. So there is an example of like Argo Rollouts, and this is one of the systems which does that. It works with special resources made for rollouts and aware of the canary process. So yeah, you need to know that, hey, which like version is like current, which version is like test one, kind of what's the desired replicas for each of them, what's the state of these, and so on. They don't have to get stuck, for example, and like there is a lot of stuff to it. Then let's also talk about webhooks for faster applications refresh. So in regular circumstances, it's really hard to know like when manifests are available with new versions. Just like something pushes it to Git and like Git doesn't have to tell us. Especially if there is a dynamic computation using customize or Helm is used for manifest, then again it gets even harder to know for sure. So most likely there is typically a setup of like periodic refresh and diff calculation, maybe like once every several minutes. We like update all applications and check, hey, are there any like changes in target manifests? But it adds some repetitive work and inefficiency. Even if there are no changes, there is some extra work to do, and like also you need to like space it out properly, because if you update all the applications, you get a spike in the load. But then to work with this, repository management systems like GitHub can offer webhooks. So you can configure some like URL that can be called when some files in the repository change. For example, if subpath related to specific application changes, the repository management system can call a webhook with that information. The continuous delivery system can like invalidate the cache and trigger a refresh for that application like immediately. It's gonna be a nice optimization. Cool, and it's probably gonna be it for me for now. If you want to learn more about this kind of systems, like check out Argo CD documentation. It's like a great system. It's a nice community, and has a lot of years of experience of building this kind of system. So yeah, thanks for watching.